This video walks you through how Microsoft Excel performs one-way analysis of variance, as well as possible further analysis to identify those samples, in this example, those medicinal tablet products, which differ statistically significantly. We use the Tukey-Kramer test for further analysis, which is best suited for the material used in this video. One-way analysis of variance is able to determine whether the means of 3 or more samples differ statistically significantly. As a hypothesis for H0, it is assumed that there is no statistically significant difference in the means of the samples. Based on the analysis of variance, Excel calculates the probability for this hypothesis. If the calculated probability is small, the limit is generally considered to be a p-value of 0.05. If the probability value p is below this limit, an alternative hypothesis is introduced that assumes that the mean of at least one sample differs from the others statistically significantly. The analysis of variance does not give an answer as to which samples have different averages. A further test is needed to clarify this issue, which performs paired or bilateral tests and determines whether there is a potentially statistically significant difference in the averages. An example of the video is the results of dissolution measurements determined from 3 different tablet preparations. Here is preparation 1, preparation 2 and preparation 3. The numbers show how long it has taken for each tablet tested to that 80% of the drug in the tablet has been released. We want to test whether the medicinal products differ statistically significantly in terms of the rate of drug release, or if one of the 3 medicines releases the medicine in the tablets faster than the others. In order to perform variance analysis with Excel, a data analysis tool must be installed. The installation can be found by first pressing the File button. Which opens the Options button. Here is the Add-ins button, from which the Analysis Tool Packer then further selected, and press the Go button. Now opens Add-ins Available window, from which tick Analysis Tool Pack. Now when you press the Data button in Excel, causes the data analysis window to open, from which, in this case, ANOVA single factor is selected. Next, select the input range where the measurement results to be analyzed are located in the Excel spreadsheet. The information may be arranged in columns as in this example. If the data is written in a row direction, the option Grouping by Rows is selected. If the table has headings in the first row, you should check that option. In this case, Excel utilizes that header information to view the results. Next, the alpha level is selected, i.e., how small the calculated probability must be in order for the H0 hypothesis to be rejected, and used an alternative hypothesis. The generally accepted alpha level is 0.05. This means that a maximum of 5% probability of making a wrong conclusion is accepted. When hypothesis H0 is rejected and the alternative hypothesis is introduced, that is, in this example there must be no more than a 5% probability of making a mistake when hypothesis H0 is rejected, which assumes that the measured mean drug release rates of all 3 tablet products are equal, and introducing an alternative hypothesis that assumes that the mean drug release rates of all tablet formulations are not equal. but differ statistically significantly. Finally, the output range is selected for one-way analysis of variance. The range can be selected from the same spreadsheet where the metrics are located, or it can be printed to a new spreadsheet or a new workbook. In this example, the print area is selected to start from cell F3, and press the OK button, after which Excel prints a summary of the calculated analysis of variance. The results show the number of tablets tested for each preparation, means and variances of release times. In the ANOVA table, the most important is the p-value, which tells the validity of the probability H0 hypothesis. In the case of this example, it is 0.0025, which is well below the critical value of 0.05. So hypothesis H0 is rejected and an alternative hypothesis is introduced, which assumes that the release times of the different tablet preparations are not equal for all samples in this case, but that there are statistically significant differences between them. The critical value of F indicates what the value of the F distribution should have been at least. In this case it should be 3.88 or higher. That the p-value is below the 0.05 level. In the case of this example, the value of F is 10.25. Thus, the probability that hypothesis H0 would remain valid is extremely small, about 2.5 per mil. It means that in the case of our example, one or more samples differ from the others. Which sample or which samples differ from each other is not directly apparent from the results of the analysis of variance. For this reason, a further analysis comparing the samples in pairs is required, and to find out which of them differ statistically significantly. The student's t-test should not be used for this paired comparison, which is valid for checking only one pair to be compared. In the case of this example, 3 pairwise comparisons must be made to go through all the alternatives. In this example, we use the Tukey-Kramer test. First, the absolute value of the difference between the means of each pair to be compared is calculated. The next 2 columns are supplemented with information on how many numerical values each comparator sample contains. Next, a critical value of Q alpha is needed. That is not directly available in Excel. For this purpose, from the internet must be searched keyword studentized range Q table, where this value can be found. The table can also be found at the link below. To find the critical value of Q alpha, it is necessary to know how many samples are compared. In this case, there are 3 samples. In addition, the number of degrees of freedom in the groups is required, which can be found in the summary table made by Excel. In this case, it is found from cell H15. Its value is 12. Look at the table for a risk level of 0.05. Degree of freedom can be found in the rows of the table. The column of the table corresponding to the case of the 3 samples is used. Here is the critical value of Q alpha for the case of the example, which is 3.773. The critical range is calculated in the next column. Cell F1 has a formula added to calculate this. The term MSW in the formula is mean square within groups. Excel calculates this term in Variance Analysis Summary section, which is found in cell I15 in this example. The next column is used to calculate whether the mean values of the samples differ statistically significantly. Excel if comparison is used. If the absolute difference in samples means is greater than the critical value, the samples to be compared do differ. If, on the other hand, the absolute difference in samples means is less than the critical value or equal to the critical value, there is a statistically significant difference in the averages of the samples. In the case of this example, the tablets of product 3 release the drug faster than the tablets of products 1 or 2. There was no statistically significant difference between products 1 and 2 in the mean tablet release rates, based on the measurement results available in this example.